Hello, everybody. This is section 1.3, a review of trigonometry. Obviously, we are not going to review everything you learned in the class trigonometry, but we will define those 6 trigonometric functions. We'll talk about the graphs. We'll talk about some identities, important ones for calculus, and then we'll solve a couple of trigonometric equations just to illustrate important principles. All right, so let's get started on section 1.3. So the beginning of trigonometry is really the unit circle. The unit circle is the circle of radius 1 centered at the origin, as you see here, right? And then we take this ray that starts at the origin, and we look at this point of intersection. Now you have an angle here measured, as you know, from the positive x-axis counterclockwise, either in degrees when you were boys and girls, or in radians as you grew into adulthood. And so the intersection of this ray with a point on the, with the unit circle, we can call that xy. So the x is this coordinate and y is that coordinate, all right? And in the most general definition, we have, well, theta is a given angle. As we said, you can measure this in degrees in certain contexts, like in applications, but on for mathematical reasons, and it'll be more clear or more clearly defined in calculus, we'll be using radians, and this will be our preferred mode of measuring and expressing angles. So the definition of the sine and cosine functions, the most appropriate definitions are from this, okay? So x, the first coordinate, is the cosine of theta, and y is the sine of theta, right? And then the tangent can be defined basically as y over x. Y over x is the tangent of theta, and as you know, when x is equal to 0, when x is equal to 0, the tangent is not defined because you have 0 denominator. Now, clearly, x and y are, well, you know, if you do it this way, you have this angle here, and we call this the hypotenuse. That is 1 in this picture, right? And so because you have x, which is the adjacent, and y, which is the opposite, sometimes, you know, you have that expression SOHCAHTOA to remember what sine and cosine are. But this is, again, this way to define the cosine and sine as x and y as the intersection point of the ray and the unit circle are the most appropriate ones. All right, so from this, it's easy to see that sine square of theta plus cosine square of theta is x squared plus y squared, which is the hypotenuse square, and that has to be equal to 1. So we immediately get this most fundamental of all of the trigonometric identities, right? So I call this the mother of all identities. And by the way, this is always and forever going to be true, forever and ever, right? So when you become a grandfather or grandmother, and if your descendants ask you what is the sine square plus cosine square, you can confidently answer 1, okay? Because that's not going to change, even if the society and the government and the policies change. All right, now, how do you measure this angle here? Well, the way to measure this angle basically is as you go around this circle, here is a circle, right? This is the x-axis, and you measure angles this way. And if the radius is 1, the complete circle, the circumference is going to be 2 pi, of course, right? So this will be pi over 2. So as you travel from this point 1, 0 along this unit circle, when you have traveled 90 degrees, your distance traveled is pi over 2, and that is your theta. That is your radian measurements. And pi is there. And by the way, this pi is the same as the pi you learned years ago. It is the real number, 3.1415, blah, blah, blah. It's the irrational number, which represents a ratio between the circumference of a circle and its diameter, right? And so, and then of course, 2 pi is going to bring you right back to this point 1, 0. And so 2 pi and pi represent the same angle on the unit circle, but clearly, you don't want to say 2 pi and 0 are equal to each other. As angle representation, the picture would look the same, but clearly 6.28 something is not equal to 0. So that is, those are not equal to each other, although they do represent the same angle. All right, so, oh, by the way, so this, way to define, maybe you learn sine as opposite over hypotenuse, cosine as adjacent over hypotenuse. Those definitions are okay as long as theta stays small, like less than 90 degrees or less than pi over 2. But see, that kind of a definition is insufficient. For instance, when you describe a negative angle or a theta bigger than or equal to 90 degrees. So we stick to these more general definitions when we talk about trigonometric functions. All right, now, everyone should know some basic values of sine and cosine. Okay, this is like learning how to play scales in piano or something, right? And if you have a hard time remembering this, if you need a calculator to know sine of 0, cosine of 0, and so on, then you really should spend some time learning this. All right, so there are some standard angles, pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, pi over 2, which is 90 degrees, and then pi, and let's just continue to skip a bunch of numbers to 2 pi. Of course, 2 pi and 0 represent the same angle. We call them the equivalent angles, and so the values will be the same at the top row and the bottom row. Okay, what's sine of 0? That would be the y value of this point right here, and of course that's 0. Cosine is 1 because this point is 1, 0. Tangent is sine divided by cosine. Oh yeah, I should say this is sine divided by cosine because it's y over x, and so tangent would be 0 here. Okay, how about pi over 6? Okay, so that would be somewhere, looks, this angle looks a little bigger than 30 degrees, but you should know that this number is, sine is 1/2. Okay, that's this y coordinate, and then the cosine turns out to be the square root of 3 over 2. And tangent is, of course, 1 divided by, well, this number divided by that number, that's 1 over square root of 3. All right, some of you have well been taught by well-meaning teachers that you should not have the denominator as a radical number. So you could write it this way. You multiply the top and bottom by the square root of 3. However, you don't have to do that anymore. Okay, you're a mature adult now, you're in college. And so having to have the denominator as a rational number without square roots, okay, maybe that was a good practice. It was a good lesson to be learned as a child. Now that you have grown, you don't have to do that. It's perfectly all right. And sometimes it's even preferred to have a square root or radical sign in the denominator. All right, so you don't have to do that for me, although you can rationalize the denominator if that is what you prefer. Pi over 4, sine of pi over 4 is equal to the cosine of pi over 4 because the degree measure is exactly 45 degrees. And of course, the tangent is, the same, I mean, this number divided by that number, which just happens to be 1. Right, when you get to 60 degrees, it'll be the opposite of pi over 6. It'll be square root of 3 over 2. 1/2 is the cosine. And then the tangent will be the reciprocal of this number, which is, of course, square root of 3. Okay, what happens at 90 degrees? Pi over 2. Sine, well, now it's at the highest point of the unit circle. So the y value will be 1. The cosine, the x value is 0. What happens when you divide 1 by 0? Remember, you are not supposed to write or say anything as obscene as this. So I'm going to quickly erase this because I don't want people to know that I speak such vulgar language. Instead of that, you just say it's undefined. Remember, the tangent function is not defined on the y-axis where the angles are like pi over 2 or 3 pi over 2. Sine of pi. Now on the other side, it's over this point. And by the way, this is how you remember this. Right? When you are asked to evaluate all of these things, just imagine this circle, radius 1, pi over 6 is here, pi over 4, pi over 3, and so on. Pi will put you on the opposite side. You know the x coordinate is -1, y coordinate is 0, and 0 divided by -1 actually is 0, so the tangent value is also 0. Now, by the time you get to 2 pi, you get the same thing as, where theta is equal to 0, so you get 0, 1, 0 as well. Okay, so this kind of thing, okay, these values, you should be able to just recall and know these numbers by heart. I have given you the definitions of the first three trigonometric functions, sine, cosine, and tangent, or in my order, cosine, sine, and tangent. And then we have the reciprocal ones. Okay, so if you take the reciprocal of sine, 1 over sine, that is called cosecant of theta. And 1 over cosine is called the secant of theta. And 1 over tangent, which is the reciprocal of the tangent function, which is cotangent. And by the way, this can also be written as cosine theta over sine of theta. These are the 6 trigonometric functions. All right, so if somebody asks you to list all trigonometric functions, you could list these: the sine function, the cosine function, the tangent function, the cosecant, the secant, and the cotangent functions. All right, now the identities. I already mentioned identities, the mother of all identities. Sine square plus cosine square is equal to 1. Obviously from this picture, but there are other ways to solve this problem. And again, I should emphasize, this continues to be very, very important as you study calculus, right? And in fact, from my a brief about 30 plus years of teaching experience at college level, trigonometry is the weakest link. Many students struggle in calculus because they struggle with trigonometric functions. So in that regard, this section turns out to be particularly important. All right, now you have learned lots of identities, I think, right? You learned many of these identities in trigonometric or trigonometry class. I'm not going to give you a whole bunch, but you should know, for instance, 1 plus tangent square. Okay, and if you forget, it's not really hard to remember. In fact, if you ask me this often, if you see me on the street or in a mall or something, which will not happen because I am never in any shopping mall. But if you stop me on the street and ask me, hey, what is this equal to? I may say, hey, give me just a few seconds, and I have to, just have a time to think about this. But 1 plus tangent square, if you can't remember it, just remember tangent. What's tangent? It's sine over cosine, right? Now, if you have tangent square, you have this. 1 can be written, how do you add 1 to this? Well, you have to have a common denominator. 1 can be written as cosine square over cosine square. And lo and behold, now you can tell what that is, because the top is sine square plus cosine square, which is 1. And now you know this has to be equal to secant square. Right? So the identity 1 plus tangent square is equal to secant square can easily be obtained even if you forget what that is. Similarly, you have 1 plus cotangent square. This time, you would have to write this as cosine square over sine square, because that's what cotangent square is. And 1 can be written with the same denominator, sine square over sine square. The top is 1, the bottom is sine squared. And so this will be cosecant squared, right? Okay, so these are the top 3 identities you probably should remember. All right, the sum and the difference, I'm just going to focus on the sum, angle sum formulas, but sine of, now I don't want to use theta because you have to have 2 Greek letters. So we'll use the first 2 Greek letters, alpha and beta. spelled this way. You should practice writing your Greek alphabet letters because these appear quite a bit. Okay, sine of alpha plus beta is equal to, and in your trig class, I think you probably learned this by drawing some pictures and struggling with this. And it's not so easy, but not so hard to prove that sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Notice here the sign is the same, plus and plus. And that is because the function is the sine function. The sine function preserves the sign. Cosine the cosine of the sum of two angles starts with the two cosine expressions. So cosine alpha cosine beta minus sine alpha sine beta. And because it's not the sine function, the sign doesn't get preserved. Cosine of a sum turns out to be the difference of a cosine term and the sine term. Okay, and by the way, if you are asked again for the difference of these, you just put this minus here, and of course, you know, basically, alpha minus beta is the same thing as alpha plus negative beta, right? So you can think of this as negative beta, which doesn't change anything because cosine of beta is the same as the cosine of negative beta. But this one does change because sine of negative beta is negative sine of beta. So that means this sign will change. Okay, so you can just modify this very easily to find your difference formula. The same thing for cosine. This will become plus, and that's all you have to know. All right, now, if you have alpha plus alpha, you have double angle. So replace beta with alpha, and you have sine of 2 alpha. What is that? Sine of 2 alpha? Oh, is this 2 times sine of alpha? No, it doesn't work that way. It's not linear. Okay, so you can't move this to the front. Can't do that, right? Why not? Well, because it's just not the right thing. Because sometimes you just can't do what seems right in your own eyes, right? Okay, so what is sine of 2 alpha? Well, you can easily think of 2 alpha as alpha plus alpha. That will give you sine alpha, cosine alpha plus cosine alpha, sine alpha. That's 2 of sine alpha cosine alpha. And so that is the double angle formula for the sine function. Cosine function, okay, again, you can do the same trick. You can replace this with another alpha. Cosine of alpha plus alpha, which is cosine of 2 alpha, is cosine alpha cosine alpha minus sine alpha sine alpha. So there is one of your double angle formulas. Okay, but I mean, these are quite different, right? But if you think about this, this is one. This is the first one. Cosine of alpha can be written as 1 minus sine alpha square. A cosine square is 1 minus sine square because of that mother of all identities, right? So you could write this way: 1 minus 2 sine square alpha. So this is the second appearance or second form of the double angle formula for cosine. Also, you can decide to write this sine square alpha as 1 minus cosine square alpha, because again, from the mother of all identities. Negative minus minus, so you have the two negatives. That would make the cosine square to be positive, and negative 1 is still there. So now we have yet another form of the double angle formula for cosine. So remember, cosine of 2 alpha turns out to have 3 formulas. And we will probably use all of these, okay? And they come in quite handy as you study certain aspects of calculus. All right, so that is what you need to do. Now, we also want to talk about graphs of these important functions with some transformations. We also want to emphasize the trigonometric equations. One of the most important skills you can learn before you start calculus is how to solve trigonometric identities, trigonometric equations. And so many people struggle with that one concept that I need to stress that. So we will cover the graphs and the trig equations in the second part of this video. All right, so let's pause for a moment, and then we can start our next segment shortly.